Okay, let's do a little chemistry tutoring. These are the topics for your test on Monday. I also made another video on Bohr models if you want to watch that. That's like 7 minutes long. This guy's a little longer, so you might want to watch it in pieces. Follow along in your notes as well. So here's what we're going to be tested on. The first thing we talked about in this unit was matter, the different phases, types, changes. We mentioned what reactants and products were. We then talked about the atom, how the idea of an atom started, what an atom is made up of, and the charges of subatomic particles. And we said some stuff about atoms, that they have mass, that there are things called isotopes that exist, periodic table, what are the rows and columns, periods and groups, what they mean, and what valence electrons are. We then practiced our Bohr models, and lastly we bonded ions and covalent bonds we'll talk about a little more. All right, so let's start with matter. Matter is basically anything that occupies space and contains mass. So basically everything, if it sort of takes up space. We said that that's different than energy. Things like light waves and sound waves are not matter because they don't take up space or have no mass. Phases of matter, the three were solid, liquid, gas, and we basically said that the difference between them was based on the molecule configuration. So solids had molecules that were very tightly packed and moved very slowly. They do move. Liquids, the molecules sort of slide past each other. And gas, the molecules are just flying in crazy directions. And you have to cover, if you notice, you have to cover the container because they would fly out as opposed to the others that wouldn't. You have to know what it's called if you go from solid to liquid, and so that's melting. Solidification is liquid to solid. This is all in your notes, so follow along. Gas to liquid is condensation, and liquid to gas is evaporation. We also said it depends on the temperature, so as you heat up a solid, it usually melts into a liquid. Raise the temperature, you raise the kinetic energy, which means the energy of movement. So you start moving those molecules a little faster, and if they move faster, they change in state or phase. We use this analogy to show you, we sort of put this picture up and said, hey, what's this analogy saying? And so the soldiers were a solid because they were very rigid and moved slowly, or not at all. The dancers were a liquid, very tightly packed, but they sort of glide around the floor. And the soccer players were a gas because they can sort of move anywhere they want rapidly. Matter exists in a couple of different ways. The first thing is an element is sort of the purest thing you can have. An element is something that retains its properties no matter how much you cut it down. And so, like for example, gold exists as the gold atom, and you can sort of build that up into this gold block. So that's an element. Compounds, you basically have different elements that are put together, bonded somehow. And then mixtures are just a bunch of compounds put together. So, for example, water is a compound, but salt water is a mixture because it has salt and water in there. That rock, granite, it's got a bunch of different minerals and elements in there, different compounds, so it is a mixture. So rocks are mixtures. We then practiced, we said compound, element, mixture, so salt, that's a compound. Trail mix, that's a mixture. Gold, element. Sand, mixture. Air, that was tricky. Some people said that it was a compound. But it's actually a mixture because you have lots of different compounds up there. You have nitrogen, you have water vapor that's in the air, you have just a bunch of different particulates and things floating in it. So air is a mixture of stuff. And then sugar is a compound made up of like carbon and hydrogen and oxygen. Okay. We then talked about how you can change matter, and basically we said you can have two types of changes. You can have physical changes and chemical changes. In physical changes, water is still water, no matter what you do to it. You can sort of bend it, cut it. You can bend water. You can cut it, you can pour it, you can sort of boil it, you can freeze it, and it's still H2O. But chemical changes are if you're bonding new things to it. So rust That's iron. And if oxygen hooks up with iron, you get iron oxide, which is what rust is. So it changes into something new. If you see some words like bend, cut, break, grind, slice, tear, shatter, boil, freeze, melt, those are all physical changes. But chemical changes are very extreme, like burning, rotting, exploding. The change is very extreme. That means it usually won't go backwards. Physical change you can sometimes reverse. Chemical changes are tougher. Ferment, corrode, and rust. We talked about how matter is made, and we said those are chemical reactions. Basically, things called reactants will combine and become products. And then we showed two movies, which I won't show here, but we said that if you take iron and sulfur and put it together, it's actually a mixture. You needed heat, which was the movie, if you remember, where they heated up the iron sulfur and they made this like rock called iron sulfide. Okay, that becomes a brand new thing. Iron sulfide is a very solid rock, and so that is a reaction. Cool. Then we talked about all the reactions are basically these atoms bonding and moving and combining and breaking apart. And so we started with the atom as the basic unit of matter, the smallest thing that matter is made up of. We said that it started with a philosophical explanation, which we again discussed that sometimes was baloney because they didn't run any tests. And so the idea was that if you took an apple and you cut it into a bunch of pieces and you kept cutting, you kept cutting, you kept cutting, you'd finally get into the smallest uncuttable piece. And so the Greek word for uncuttable is atomos, which is where atom came from. We now know that that atoms are actually made up of smaller things like protons, neutrons, and electrons. Those are called your subatomic particles. The nucleus, which is positive, is surrounded by a negative cloud, and they found out that the nucleus is made up of a positive charge because there are protons in there. Interestingly, neutrons were like the last particles to be found because they are neutral, so they really couldn't detect them. And then the outside are electrons. Those guys have a negative charge on the outside. So if the negative equals the positive, then the atom is considered neutral overall. So what determines what element an atom is? So what atom is this? Well, it depends on the number of protons. So you can just count the number of protons and it tells you this is its atomic number, and the atomic number can be looked up on the periodic table. So this element is helium, because it has two, if you notice those two red dudes, two positive protons. Okay? Yay, balloony. Okay, what determines mass? Well, we said that the mass is protons plus neutrons. Well, why not electrons? This is called the atomic mass, by the way. Atomic mass is the entire total of protons plus neutrons. But how come electrons are ignored? Okay, before that, these are the elements that you have to know. If you want to pause the video so you can sort of follow along your periodic table, but you have the list in your notebook. Okay, I guess we'll get back to the electron question in a second. Why we don't use them in the mass. Just hold on to that. The slide must be out of order, but here we go. C is for cookie. No, it's not. It's for carbon. This is the chemical symbol. And the chemical symbol usually has a couple of things around it. Two numbers. Usually larger numbers on the top, smaller numbers on the bottom, which helps you kind of figure out what stuff is. The atomic mass is the one on the top, and the atomic number is the one on the bottom. So on the test, if I give you this 12 and 6, you should be able to tell me how many neutrons this carbon has. The answer is 6, by the way, because 6 plus 6 is 12. Oh, so back to this. Here's where the slide was. Why does atomic mass not include electrons? And we said that electrons are so light. There's basically about almost 2,000 electrons in one proton, the equivalent of like pennies. You had to get all the pennies to equal a bowling ball. So they're ignored. Ignored. So sad. We then discuss isotopes. What were isotopes? And isotopes were different versions of elements. They were actually heavier than the quote normal element. They're more rare. That's why they're not the normal one. But carbon, for example, this is carbon 13. It's just a different amount of neutrons. So if I gave you this on a test, I would ask you, how many neutrons does carbon 13 have? And you would say 7, because 6 plus 7 is 13. Now, why does this at the bottom, if you look on the periodic table, why does carbon's atomic mass 12.011 instead of like a nice average like 12.5? And the mass kind of tells you which isotope is the most common. So carbon 12, by the look of this number, is more common than 13 or 14. Our periodic table, how nice. We looked at a periodic table and we said, hey, the rows that go across are called periods and the columns are called groups. And we talked about a little bit, hey, what does that mean going across? All those elements going across. What are some trends? And the trends are, as you move across, you'll get more protons. Obviously, you go from 3 to 4 to 5 to 6. Each number is a new atomic number, gives you more protons. The other thing is, as you move from left to right, the number of valence electrons will usually increase. This is ignoring the middle, by the way. Remember, we fold our periodic table to ignore the orange section here. So we have 8 columns, and columns 1 through 8 tells you the valence. Valence, just as a little reminder, valence electrons are the outermost electrons. Now groups are moving down, and these guys are similar because they actually have, since they have the same number of valence electrons, the outside ring, they will react the same as the dude above them or the dudette below them, okay? So, here's a typical question. Who am I? I'm an element. Do you notice I made this an isotope? Instead of putting 4p and 5p, 4p and 4n, yes, I made the neutrons be a little bit different, just so you could be ready for that. But it doesn't matter, we don't need that for the element. This is beryllium, and beryllium has 2 valence electrons. Why don't we use electrons or neutrons to determine the element? Well, we don't use electrons because it turns out that elements can gain or lose electrons. And we don't use neutrons because we already know that neutrons can be isotopes, which are weirdos. Bohr model. All right, we already did a video on this, so I'll be really quick. Neon, if I ask you to draw a Bohr model for neon, you have to look on the periodic table first. You find out what number it is. It turns out it's number 10. So in the nucleus, you write 10p, 10n. You then draw some rings. The first ring gets 2. Second ring gets 2, 4, 6, 8. That gives you 10 total. Now, neon is a noble gas, remember? It's one that's super, super, super happy and does not bond. Please know why it doesn't bond with anyone else. Its electron valence shell is full, so it does not like to interact with other elements. So let's talk about bonding. We basically said that, how do elements bond? Well, it basically means that one element is attracted to another usually. And we said there were 2 types of bonds, ionic, covalent. Oh yeah, sometimes there's a third. Ionic is when the 2 elements are joined by opposite charges, and I'll show you that in a second. And covalent, it's where the elements share electrons. So, atoms will either lose, gain, or share electrons to fulfill what's called the octet rule. The octet rule, remember, is having 8 on the outside. So if they lose or gain, they are called ions, okay? If an atom loses or gains. So here's how that works. Sodium, it hates that it has 1 valence electron on the outside of its ring, so it loses it. It becomes what's called a cation. Remember the way we remember cations? Cats have paws, okay, cat, paws, got it. Anions, like this chlorine, are negative, and because they gain an electron. Now, I know it's really confusing for some of you. It was a little crazy that, hey, sodium is getting a plus, but it's losing something. Remember, the reason it's plus is because it's losing something that's negatively charged. So since sodium loses 1 little negative guy, it becomes more positive. Chlorine, who loves to get that last electron, is gaining an electron that's negative, so it gets a negative number. Now, we don't write 1s, remember, so you just write plus and minus. So this guy lost an electron and chlorine gained an electron. So how do they hook up? Well, they hook up because they have charges now. So they make an ionic bond based on their opposite charge, sort of like a magnet. And this NaCl makes table salt. Here's an example of one of our sort of projects. This is a project we've been talking about. This is the diagram that I made to show you what the project kind of looks like. And if you notice, the blue dude was on the guy on the left, but the dude on the right with the green electrons needed that one to fill out its outer shell, so it took it. And now they are hanging out together because one has a positive charge and one has a negative charge. Okay, so they both are happy. Their outer rings are filled. All right, so again, the octet rule is, I jokingly called it the I want desperately to be a noble gas rule, meaning like chlorine is one away from having the electron configuration of argon, and oxygen is 2 away from being neon, and magnesium just has to lose 2 to be neon. Now, they don't become that element, they just have electrons that behave, they're stable. They have electrons that behave like neon and argon. So the noble gases, again, are the guys all the way on the right of the periodic table. So, if I ask you, hey, how does the octet rule affect this atom? The octet rule says you want 8 on the outside, so this atom will lose its outer 2. Ionic bond formulas is something you need to know. So you'll basically be writing the chemical letters like Na and Cl, but you'll also have to put subscripts if it gets subscripts. Here's what I mean. The first thing you need to know is the charges of everything. Now it's pretty easy because it's whatever column they're in. Remember, with the periodic table folded. So column 1, those guys have a positive 1 charge. Column 2, they have a positive 2 charge. And column 3 has a positive 3 charge. We'll ignore 4 and 5, and we'll only talk about 6 and 7. 6 has a negative 2 charge, and 7 has a negative 1 charge. So, what will the charge of this element be? If it loses those 2, it's going to be 2 positive. Okay? Bing! Thank you. So how do you know its charge? The best way to know its charge, again, is by the column. So what you do is you're going to get this periodic table on your quiz. The only information you have is the atomic numbers and the columns. Remember, ignore this orange section when you're talking about valence and charge, okay? So let's say, for example, I give you, let's just say, potassium right here. You say, hey, potassium's in the first column. So that means it has 1 valence electron on its outer shell, and it hates that electron, so it's going to lose it. So potassium will have a positive charge as soon as it gets rid of that negative electron. If I give you chlorine over here, well, that guy's going to have a negative charge because it needs 1 more electron. And so chlorine will have a negative charge. These guys will have -1, these guys will have -2. Okay, these guys will have +1, and the second row will have the first column will have +1, and the second column will have +2. Okay. So let's do ionic formulas. Let's say, for example, I give you 2 elements, potassium and oxygen, and you have to tell me how they hook up. Potassium's in the first column, so it's plus. Oxygen is in the 7th column, the 6th column. It needs 2 more, so when it gets 2, it'll be 2 plus. So you do what we called the crisscross rule, and this is the formula for potassium oxide, K2O. That means you need 2 potassiums to hang out with every 1 oxygen. So try these. If you want to pause the video, try them, and then I'll do them in a second. We're back! Okay, I hope you paused the video. NaBr. Na's in the first column, Br's in the 7th column, so the way you write it is NaBr, because one was plus and one was minus. Calcium chloride, or calcium and chlorine, become calcium chloride, which looks like this. The reason there's a 2 on that chlorine is because calcium had a 2 plus charge. And aluminum and oxygen, that one's the toughest one. Aluminum is 3 plus, and oxygen's 2 minus. So using your crisscross rule, Al2O3, aluminum oxide, okay? Yay! We then talked about covalent bonds really quickly, but covalent bonds are the sharing of electrons, with hydrogen being the easiest one. Basically, the way covalent bond works is they don't the element won't gain or lose any, but with the sharing, it feels like it has two. Okay, here's what I mean. So these guys right here, they both have 7 on the outside, and they're very depressed. They want one more. Now, one way they could do it is grab a floating one and become an ion, but the other way they could do it is like this. If their shells crisscross, those two make each of them feel like they have 8 on the outside. You notice? 2, 4, 6, 8. Even though they're different electrons, they feel like they're part of each one. So this guy bonds together with a covalent bond. That's sharing. This is one way to look at fluorine, the same covalent that we've been talking about. Basically, the electrons share, and you make a dash in there, and the dash shows the bonding. The extra dots that are around the F's, if you see those dots, that's how many leftover valence electrons there are after the bond. So, oxygen. How would oxygen bond? Well, oxygen bonds with what's called a double bond. Sometimes you can't just make a single bond, so it doesn't really work. So this I'll show you a little better in class with a diagram, but a double bond forms. And if you notice on the outside of each oxygen, 1, 2, 3, 4, 5, 6, 7, 8. They feel like they have 8 if you go around, but they actually each have 6. And then there's something called a triple bond, which nitrogen does, and this I will show you in class as well. But sometimes they will share triple bond, and each one feels like it has 8. Okay? So, covalent bonds for water, hydrogen fluoride, that's hydrogen and fluorine together, CH4 and NH3. Okay? If you draw the covalent bonds for those guys, water, hydrogen fluoride, CH4, NH3, if you want to pause and try them, you can. But they look like this. Hydrogen fluoride, water is the second one, NH3 is the third one, and CH4 is the fourth one. Okay, so we, again, will practice this a little bit. And then you remember this fantastic thing, fill in the blanks. So basically it works like this. I either have to give you, two things for you to figure them all out. So here we go. Let's start with the top row, 20 protons. The best way to figure out what's going on here is you go to the periodic table, go to number 20. Protons, the atomic number is 20. The element symbol, atomic symbol is Ca. Calcium is number 20. We then said that if this guy's neutral, if he's got 20 protons, well, he's going to have the same number of electrons. Cool. Now, neutrons, the way you figure that out is with a little math. Because protons plus neutrons give you atomic mass. So this would be 22. You get it? 20 plus 22 is 42. Protons plus neutrons is atomic mass. All right, the second one's cool because if you have nitrogen, well, you know that's N. Next, you do the atomic number is 7. That means it has 7 protons, and because the dude is neutral, it's going to be 7, 7, 7, 7. If you notice the same as the top row, those numbers will all be the same. And atomic mass is 8 plus 7, ding, 15. Woohoo! Nitrogen. Sorry, nickel. We just did nitrogen. Nickel, you get neutrons is 30. Well, I can do some information here. If I look up nickel, I know it's called nickel. And its atomic number on the periodic table is 28. That means it has 28 protons and has 28 electrons because it's neutral. Protons plus neutrons, bing, 58. Correct. All right. Good luck, guys. If you need any additional help, come see me.